A dwarf planet 4 billion miles away is running its own private refrigerator, cooling itself down using nothing but the haze in its own sky, and nobody expected a world that small and that cold to be doing anything like this. Stick around because I'm about to walk you through what scientists actually just confirmed about Pluto. And hit subscribe now because this channel breaks down real space discoveries without the exaggeration. And you do not want to miss what else is coming out of the outer solar system. Let's go back to where this story actually begins, because Pluto's history is stranger than most people remember. In 1930, a 24-year-old assistant named Clyde Tomb, working at an observatory outside Flagstaff, Arizona, was given one of the most tedious jobs imaginable. He photographed the same patch of night sky on different nights, then flipped back and forth between the plates, searching for a single point of light that had shifted position. Most nights produced nothing at all. Then, on one plate in February of that year, something moved. A tiny dot had shifted against a background of fixed stars, and that dot became Pluto. For the better part of a century afterward, it held the title of the ninth planet in our solar system, even though it was so distant and so small that astronomers could only guess at what it actually looked like up close. There is a moment in science when everything you thought you knew turns out to be wrong. Not a little wrong, completely embarrassingly wrong. And the story of Pluto is exactly that kind of moment, except most people missed it because they stopped paying attention after 2006. That was the year a room full of scientists held a vote and decided that Pluto was no longer a planet. Just like that, the world that had sat in every classroom poster, every science textbook, every child's drawing of the solar system for 76 years got stripped of its title, voted out, demoted, filed away under the label of dwarf planet, and mostly forgotten by the general public. And here is the thing that nobody told you. That decision turned out to be almost completely beside the point, because while people were busy arguing about what to call Pluto, the actual scientists kept working, and what they eventually found, what a spacecraft discovered in 2015, and what the James Webb Space Telescope has been quietly confirming ever since, rewrote nearly everything we assumed about that small frozen world sitting at the edge of our solar system. But let's back up, because to understand why any of this matters, you need to understand just how little we actually knew about Pluto before anyone ever got close enough to look. For most of the 20th century, even the most powerful telescopes on Earth could not tell us much. Pluto was a blur. A tiny smudge of light so faint and so distant that scientists could track its orbit reasonably well, but almost everything else, its size, its surface, whether it even had an atmosphere at all, those were genuinely open questions for decades. Some early estimates guessed that Pluto was enormous, big enough to be tugging on the orbits of Neptune and Uranus with its gravity. That turned out to be completely wrong. The gravitational wobbles scientists thought they were seeing were later traced back to measurement errors, not to Pluto at all. In other words, a huge chunk of what the public believed about Pluto for generations was built on guesswork stacked on top of more guesswork. No real data, no close-up images, just estimates and assumptions that nobody had the tools to actually test. So when Pluto got demoted, the world shrugged and moved on. Small, cold, unimportant, easy to ignore. That assumption did not survive contact with real data. In July of 2015, after traveling for 9.5 years across billions of miles of empty space, NASA's New Horizons spacecraft finally reached Pluto. It had exactly one chance to see what was there. No orbit, no second pass. Just a narrow window lasting a few minutes where it had to capture as much as it possibly could before flying on into the outer solar system forever. What it sent back stopped scientists cold. Stretched across the surface was a massive, pale, heart-shaped plane, smooth, strangely young-looking, completely out of place against the ancient cratered terrain that surrounded it. Mountains made of solid water ice rose more than 10,000 feet into a thin, hazy sky, and not soft, fluffy ice the way you might imagine it. At nearly 400 degrees below 0 Fahrenheit, water ice stops behaving like ice at all. It becomes as hard and dense as solid rock, hard enough that it would ring almost like metal if you struck it. Fields of nitrogen ice appeared to be slowly churning in giant circular patterns beneath the surface, hinting at some kind of heat and motion happening deep inside a world that everyone assumed was completely frozen and dead. And above all of it, layer after layer of blue haze rose hundreds of miles into Pluto's sky, catching the sunlight in a way that made Pluto look almost alive. This was not a leftover chunk of rock at the edge of the solar system. It looked like a world still in the process of becoming something, but here is the painful part. New Horizons only got that one look. It captured what it captured, kept flying, and was never coming back. Whatever it missed during that single pass was going to stay a mystery, possibly forever. Scientists spent the next several years arguing over the data, building models, making predictions. But what they really needed was not a better photograph. A photograph only shows you the surface. What researchers needed was a way to read Pluto's chemistry directly, to figure out what that atmosphere was actually doing, what it was made of, and how it was behaving, all from millions of miles away, without ever sending another spacecraft. That is exactly what the James Webb Space Telescope was eventually able to do. And what it found did not just confirm the strange things New Horizons had suggested. It added entirely new layers of weirdness that nobody had predicted. A type of climate that does not exist anywhere else we have ever studied. A chemical process that has been quietly running for 4 billion years, and a frozen moon slowly being painted a different color by material leaking off Pluto itself. We are just getting started. Stay with me, because the next part of this story is where things get genuinely hard to explain. Here's something that most people do not realize about the James Webb Space Telescope. It is not a camera, not really. Yes, it takes images that show up in news articles and get shared millions of times online. But what makes Webb truly different from anything that came before it is not its ability to take pretty pictures. It is its ability to read light itself. When light bounces off a distant object and travels through space toward Webb's mirror, the telescope breaks that light apart into its individual wavelengths, the way a prism splits sunlight into a rainbow. And hidden inside those wavelengths is information, precise, detailed, chemical information. Which molecules are present in an atmosphere? How warm different layers of that atmosphere actually are? How gases are moving and changing over time? All of it encoded in light, and all of it readable by Webb's instruments without a single spacecraft ever leaving Earth. That ability sounds straightforward enough until you understand the specific problem Webb had to solve before it could tell us anything useful about Pluto. Pluto has a large companion moon called Charon. About 750 miles across, Charon orbits so close to Pluto that from Webb's point of view, billions of miles away, the two worlds sit almost on top of each other in the sky. Earlier telescopes had tried repeatedly to isolate Pluto's individual thermal signal, to read its atmosphere separately from Charon's, and they failed, every time. Not because the signal was not there, but because their instruments simply could not tell how much of the heat they were detecting was coming from Pluto, and how much was bleeding in from Charon sitting right next to it. Webb's much larger mirror and its far more sensitive infrared instruments finally cracked that problem. Starting in 2022, once its instruments were fully calibrated, Webb began turning its attention toward Pluto, and what came back over the following years was not simply a prettier picture. It was closer to a full medical diagnosis of an entire world. The first major finding goes back to a prediction that most scientists had quietly dismissed when it was first proposed. In 2017, a planetary scientist named Shi Zhang, working at the University of California, Santa Cruz, suggested something that sounded almost backwards. On Saturn's moon Titan, the thick haze in the atmosphere acts like a blanket, trapping heat and warming the surface below it. Zhang argued that Pluto's haze was doing the exact opposite. Instead of trapping heat, it was absorbing sunlight high in the atmosphere and then radiating that energy straight back out into space as infrared heat. Faster than Pluto's extremely thin atmosphere could hold onto it, the haze was not acting like a blanket at all. It was acting like a radiator, actively pulling heat away from a world that already had almost none to spare. Most of Zhang's peers were skeptical. It was a reasonable idea, but nobody had the tools to test it. There was no instrument sensitive enough to cleanly separate Pluto's faint atmospheric signal from everything else around it. Then Webb came online. A team of researchers led by astronomer Tanguy Bertrand at the Paris Observatory used Webb's mid-infrared instrument to measure Pluto's atmosphere directly. The results, published in the journal Nature Astronomy in June of 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the haze particles suspended within it. And not just a little cooled. The atmosphere turned out to be roughly 30 degrees Fahrenheit colder than earlier models had expected, even after accounting for how far Pluto sits from the Sun. Researchers now describe this as a genuinely new kind of climate, one that follows rules we have not seen operating anywhere else in the solar system. Every other atmosphere we have ever studied, whether it belongs to a planet, a moon, or anything in between, fits into categories we already understood. Pluto does not fit any of them. Scientists put it plainly. Pluto is not simply cold because it sits so far from the Sun. In a very real sense, Pluto appears to be actively refrigerating itself. And that discovery opened up an entirely new set of questions, including whether similar hazes might be shaping the climates of other distant icy worlds, like Neptune's moon Triton, and whether Pluto's atmosphere might give us a working model of what Earth's own sky looked like billions of years ago, long before oxygen ever started building up in our air. The second discovery is quieter, but once you actually sit with it, it might be the strangest one of all. Pluto's atmosphere is thin. Unimaginably thin by Earth standards, about 100,000 times less dense than the air you are breathing right now. But even the tiny amount of sunlight that reaches Pluto, roughly 1,000 times fainter than the sunlight hitting your skin on a clear day, is enough to start breaking things apart. Methane molecules floating high in Pluto's atmosphere absorb that faint ultraviolet light and shatter. Their fragments drift and recombine into heavier compounds. Those compounds keep combining into heavier ones still, forming a slow chemical waterfall that eventually produces reddish-brown particles called tholins, which drift downward through the haze and settle onto the surface below. New Horizons caught early evidence of this process back in 2015. More recent observations have continued to reveal how it actually works step by step. Here is the detail that tends to stop people cold when they hear it. Tholins belong to the same broad family of organic molecules that some researchers believe may have once rained down onto early Earth, providing raw chemical building blocks for the kind of reactions that eventually, over billions of years, led to life. On Pluto, that same basic process has apparently been running continuously for roughly 4 billion years, a slow, unbroken chemical snowfall of biological building blocks, landing on a surface that is simply too frozen for any of it to ever spark into something alive. Think about that for a moment. A world sitting at the very edge of our solar system has been quietly assembling the ingredients for life over and over again for longer than complex animals have existed on Earth. And it has absolutely nothing to show for it because the cold is simply too extreme for any of it to go further. That gap between what is possible in chemistry and what actually happens in reality, between the ingredients and the outcome, is something scientists are still trying to understand, and Pluto, sitting there in the dark, running this experiment on a 4 billion year timescale, might be one of the most important natural laboratories we have for studying it. But there is still one more discovery waiting. And it involves Charon, that large companion moon, slowly turning a different color because of what Pluto keeps leaking into space. Charon does not look like much at first glance. It is a battered, heavily cratered ice moon sitting about 12,000 miles away from Pluto, orbiting so closely that the two worlds are essentially locked in a permanent face-off, each one always showing the exact same side to the other, neither one ever turning away. From the surface of Pluto, Charon would hang in the sky completely motionless, never rising, never setting, just sitting there like a giant frozen companion that never leaves. For a long time, scientists considered Charon fairly unremarkable. Old, cratered, made mostly of water ice. The kind of world that does not make headlines, except for one thing that nobody could explain. Its poles are the wrong color. Most of Charon's surface is the pale grayish-white you would expect from ancient water ice, but at its poles the color changes completely. Deep, unmistakable reddish-brown stains spread across both polar regions, darker than anything else visible on the moon, darker in fact than most surfaces anywhere in the outer solar system. Scientists had suspected for years that this coloring was somehow connected to Pluto. They just could not prove it. The mechanism turned out to be stranger and more elegant than most people expected. Because of the way Charon is tilted as it orbits alongside Pluto, its north polar region spends multiple decades at a time in complete darkness. No sunlight, no warmth, just an unbroken stretch of total darkness that can last for 20 years at a time. During those long polar winters, methane gas slowly leaking out of Pluto's atmosphere drifts across the 12,000 miles of empty space between the two worlds, gets pulled in by Charon's gravity, and freezes solid onto that dark, bitterly cold polar surface. It has nowhere to go. There is no warmth to keep it as a gas. It just lands and sits there, building up layer after layer over the decades. Then the long winter ends. Sunlight slowly returns to Charon's pole. And here is where things get interesting. The sunlight does not simply melt the frozen methane away the way you might expect. Instead, ultraviolet radiation and cosmic rays pour into that accumulated layer of frozen gas and start breaking the molecules apart, reassembling the fragments into heavier, more complex compounds. Reddish-brown organic material, the same family of compounds forming on Pluto's own surface from its own chemical processes. Except on Charon, once this material forms, it does not evaporate. It is locked in permanently, baked into the surface by radiation, building up thicker and darker with every cycle. A 2016 study first laid out this mechanism in detail, showing clearly that methane escaping from Pluto was traveling across space, landing on Charon, and slowly being converted into that dark polar staining. But Webb's more recent observations have added an entirely new chapter to this story. In October of 2024, a research team led by Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of two unexpected chemicals frozen directly onto Charon's surface: carbon dioxide and hydrogen peroxide. The same carbon dioxide leaving your lungs with every breath you take, and the same hydrogen peroxide sometimes used to clean a wound, both sitting frozen on the surface of a moon 4 billion miles from Earth. The carbon dioxide most likely came from underground material inside Charon, exposed when ancient impacts punched craters through the surface ice. The hydrogen peroxide appears to have formed through years of radiation striking Charon's water ice and slowly rearranging it at the molecular level into something new. Neither chemical had ever been confirmed on Charon before, and their presence adds yet another layer of complexity to a moon that was supposed to be simple, quiet, and unimportant. Two worlds, constantly exchanging material across 12,000 miles of empty space, one slowly leaking its atmosphere into the dark, the other quietly catching it, transforming it, and wearing the evidence as a permanent stain. That exchange has apparently been running since long before either world had a name, and we only figured out the details because a telescope the size of a tennis court happened to be pointed in the right direction at the right time. But Charon is not even the most unsettling part of this story. Because while scientists were mapping the connection between the two worlds, the surface of Pluto itself kept producing things that had no business being there. Go back to the original New Horizons images. Somewhere in a region researchers named Tartarus Dorsa, the spacecraft photographed something that had never been documented anywhere else in the solar system. Towering rows of jagged ice blades, some reaching more than 1,500 feet high, made entirely of frozen methane and arranged in long parallel ridges stretching across the landscape like the teeth of some enormous comb half buried in the ground. Smaller versions of these formations exist on Earth. They are called penitentes, and they form in certain high-altitude deserts where sunlight hits a frozen surface at an angle and causes it to erode unevenly, carving out taller sections while the lower areas wear away faster over time. On Earth, they rarely grow taller than an average person. On Pluto, the same basic process appears to have played out over a vastly longer timescale, using frozen methane instead of water, scaling those blades up to the height of skyscrapers. A 2025 analysis of the original New Horizons data suggests these methane ice blades may wrap all the way around Pluto's equator, covering as much as 60% of it in a continuous ring of frozen, jagged terrain. Then there are the mountains that should not exist at all. South of Pluto's famous heart-shaped plain, two enormous isolated peaks rise out of the surrounding landscape without any obvious explanation. One stands roughly 13,000 feet tall, and the other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanic structures here on Earth. Both of them have deep depressions at their summits. Both are ringed by fractures. Both have lumpy, uneven flanks that look uncomfortably similar to the hardened flows of cooled lava. Except there is no molten rock on Pluto, nothing close to it. If these mountains are what they appear to be, they are cryovolcanoes. Structures that once erupted not with melted stone but with a thick, pressurized slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. Scientists are still debating whether they formed from a handful of massive single eruptions or from many smaller events spread across a much longer stretch of geological time, but either interpretation points toward the same deeply unsettling conclusion. Something inside Pluto, at some point in its relatively recent geological history, was warm enough to push liquid material all the way up through miles of solid ice to the surface. And that internal warmth leads directly to the most debated, most extraordinary idea surrounding Pluto today. One that scientists currently cannot prove, but cannot dismiss either. Somewhere beneath Pluto's frozen surface, roughly 100 miles down, there may be an ocean, not frozen, not solid. Liquid water, sitting in total darkness, under enormous pressure, kept from freezing by the slow radioactive decay of elements deep inside Pluto's rocky core. An ocean that has possibly been there for billions of years, completely sealed off from the universe above it, never touched by sunlight, never exposed to open space, just sitting there in the dark, silent and hidden beneath a shell of solid ice thicker than most mountain ranges on Earth are tall. Now, before you dismiss that as science fiction, understand that this idea is not coming from nowhere. It is coming from patterns. Patterns in the surface that keep pointing toward the same uncomfortable conclusion, no matter how many different ways scientists look at them. Cracks and ridges spread across Pluto's surface in arrangements that fit almost exactly what you would expect to see if a layer of liquid water underneath was slowly shifting and pushing against the crust from below. The famous heart-shaped plane, that massive pale feature that shocked everyone when New Horizons first photographed it, sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice seems to be concentrated just beneath the surface. And those cryovolcanoes, those enormous mountains with their summit depressions and their lava-like flanks, are almost impossible to explain without some source of internal heat pushing material upward from somewhere deep below. None of this is proof. Scientists are careful about that. There is currently no way to confirm a subsurface ocean on Pluto without sending something back there capable of actually measuring it directly. But the pattern of evidence keeps growing, and the more it grows, the harder it becomes to wave it away. Here is why this particular idea matters so much beyond just Pluto itself. Scientists already strongly suspect hidden liquid oceans beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons. Enceladus makes it almost impossible to deny. It has geysers of water vapor erupting directly out of cracks in its surface and shooting hundreds of miles into space. The ocean beneath it is essentially announcing itself. But Europa and Enceladus are relatively close to the Sun, as outer solar system objects go. They sit near giant planets whose powerful gravity squeezes and flexes their interiors, generating heat through friction. That kind of tidal heating makes a subsurface ocean easier to explain. Pluto has none of that. It sits alone in the cold, billions of miles from the nearest giant planet, with no obvious external heat source pushing energy into it. If Pluto is hiding a liquid ocean purely through the slow burn of internal radioactive decay, that changes something fundamental about how scientists think about where oceans can exist in the first place. It would mean that liquid water, the single ingredient that every definition of habitability requires, might not be as rare in the outer solar system as anyone assumed. It might be hiding everywhere, beneath dozens, possibly hundreds of icy worlds scattered across the Kuiper Belt, sitting quietly in the dark, waiting to be found. And that thought leads to the final piece of this story, the one that tends to stay with people long after the specific details start to fade. Pluto is not alone out there. It sits inside the Kuiper Belt, a vast ring of frozen debris stretching far beyond the orbit of Neptune. Astronomers estimate there are hundreds of thousands of objects in that region larger than 60 miles across. Beyond the Kuiper Belt lies the theorized Oort cloud, an enormous shell of icy bodies stretching outward so far that it reaches roughly a quarter of the way to the nearest star. Together, these regions likely contain more than 1 trillion individual objects. Worlds, in a sense, or at least the beginnings of worlds. And here is the number that puts all of that into perspective. New Horizons, the only spacecraft that has ever traveled deep enough into the Kuiper Belt to photograph any of its larger residents up close, has managed close flybys of exactly 2 objects, Pluto, and a much smaller, more distant body nicknamed Arrokoth. 2 objects out of hundreds of thousands. The rest of that enormous region of space remains almost entirely unexplored, a vast, dark territory that we have only ever glimpsed from billions of miles away as faint points of light against the black. If Pluto, one of the 2 we actually looked at, turned out to be actively refrigerating its own atmosphere, slowly painting its companion moon with leaked chemicals, possibly hiding a liquid ocean, and growing methane ice blades the size of skyscrapers across 60% of its equator, what reasonable argument is there for assuming the rest of those worlds are boring? There is none. That is the honest answer. Right now, the James Webb Space Telescope is our only working tool for learning more. It checks back in on Pluto every few months whenever Pluto swings back into its field of view, adding another data point each time and almost always making the overall picture stranger than it was before. There is no funded mission heading back there. No orbiter, no lander, nothing currently on the books. The journey alone would take the better part of a decade, and outer solar system exploration has rarely been treated as a priority, when faster, cheaper missions closer to home are always competing for the same limited funding. So for now, Webb watches and waits, and every few months sends back another piece of data that reminds scientists they do not fully understand the world they are looking at. The 2006 vote that stripped Pluto of its planetary status was supposed to be the end of its story, a tidy conclusion. Small world, wrong category, file it away, and move on. Instead, it turned out to be the beginning of a completely different set of questions. Questions about hidden oceans, about self-cooling atmospheres, about organic chemistry running for 4 billion years on a frozen surface, about what is quietly happening in all those other dark, cold, unexplored worlds sitting out there at the edge of everything we know. Pluto was never the dead end of the solar system. It was always the door. We just had to get close enough to see it.